and welcome back. In this video, we're going to introduce the concept of vertical division, and we'll start off learning the concept dividing two-digit numbers by one-digit number. Let me first introduce what the vertical division format looks like. Here's a problem that maybe looks unfamiliar, but you know what this is if I just translate it into a different format. So this problem right here is the same thing as just 40 divided by 6. This symbol over here is the division sign, and the number that you're dividing goes inside the box, and then the number you're dividing by goes right to the left of the box. This is how you can read division problems from now on. So, how do we get to solving this problem? The first step to solving vertical division is to look at each digit by itself first, starting from the left. You'll figure out that vertical division is really useful for when you get to much larger numbers and it goes beyond the scope of the multiplication table, so you have to start using the method in order to be able to solve the problems. So maybe right now it seems a little bit excessive, but later on it will become much more useful for solving complicated division problems. So the first step is always to see if we can fit 6 into the first digit, 4. Always look at the first digit by itself and look at it as a number in itself. So not 40, but just the number 4. In this case, 4 is less than 6, so we can't put 6 into 4. So that's when we extend our gaze to look at both digits, or the first two, which in this case is all of the digits. Now we're trying to see how many times we can fit 6 into 40 without going over 40. So the closest we can get using our knowledge of the multiplication table is 6 times 6, which is 36. So we write the number that we're multiplying by over the last digit that we counted. So we're writing the 6 over here. If we could have fit 6 into the 4 over here, we would have written the 6 on top of the 4. But since we're looking at the first two digits, we're writing the 6 on top of the last digit that we're counting. And what we do after this is we multiply. So 6 times 6 is 36. And we're going to write that under the 40. Now what we're going to do is subtract. 40 minus 36 is equal to 4. Our next step is to see whether we can put 6 into this new number that we just subtracted. Since we can't, this becomes our remainder. So we're going to write it up here, off the edge like that. And we have our answer. Our answer is 6 remainder 4. Now, let's try this again with a different problem. (45) divided by 7. Again, our first step is to look whether we can put the 7 into the first digit, 4. We can't, so let's look at the first two digits, 45. How many times can we put 7 into 45 without going over 45? The closest we can get is 7 times 6, which is 42. So we're going to write the 6 on top of the last digit that we counted. We multiply, 7 times 6 is 42, and then we put that answer under the 45, and we subtract. 45 minus 42 is 3. We can't fit 7 into 3 anymore, so 3 becomes our remainder. And we're going to write it 6 remainder 3. Let's try one more problem. we're going to do 83 divided by 3. Again, our first step is to see whether 3 can fit into just the first digit alone, 8. It can. This time it can. So what's the first time? How many times can we fit 3 into 8 without going over 8? The answer is 3 times 2, which is 6. So we're going to write the 2 on top of the 8 this time, because this is the only digit that we're considering. And then we multiply. 3 times 2 is 6. And then we subtract. Ignore the 3 for now. So 8 minus 6 is equal to 2. Now we have this other digit to worry about. So our next step is actually to bring it down. We're going to carry it down like this, past all this business, and we're going to just put it right next to the 2. You notice that when we did the 8 minus 6, we got 2. We can't put 3 into 2. That's our sign that we picked the right number to put on top. We'll see later on when we have to start guessing, because it goes beyond the multiplication table, that comparing this number to the number that we're dividing by is a great indicator of whether we have the right answer on top or not. So now back to this problem. We bring down to 3, and so now we have the number 23. And now we're going to consider the number 23. Now we're looking at how many times can we put 3 into 23 without going over 23. If you remember the multiplication table, you'll remember that 3 times 7 is equal to 21. So that seems to be the closest we can get. So let's write 7 on top, and then multiply. 3 times 7 is 21, and we subtract again. 23 minus 21 is equal to 2. Now we can't put 3 into 2 anymore, and we don't have any more digits to bring down. So 2 is our remainder. And our answer is 27, remainder 2. And from now on, when we do long division problems, I'll have each stage and answer or digit of the answer written in a different color so you can see which part of the problem corresponds to which part of the answer. That's all for today. Thanks for listening, and see you next time.